Right, so let's try this out. Now, the whole portion, right, did a lot of background information on how to find stuff, how to do this now. Now we got to figure out the last major thing of a confidence interval, okay? So there are three parts of a confidence interval. That's finding the margin of error respectively, so finding this number itself, depending on which situation we're in, okay? Next thing is actually constructed, meaning finding these two numbers. So adding it and subtracting it respectively to its, estimated mean. And then lastly, the most important thing is interpreting your confidence interval. In other words, you're writing a sentence based on what it actually means. So what does this confidence interval actually mean to the question? Okay. Now I'll give you guys a little template you guys can always use to help you guys out when it comes to it. So the interpretation will always look at this nice template. So we are percent. So you're going to figure out, you're 95%, 89%. So we are blank percent confident that the population parameter, so the parameter is going to be either P, mu, or sigma, right? The population proportion, population mean, population standard deviation, okay? So whatever that is, of, now this right here is going to relate it back to the question itself, meaning the whole thing is, what are you finding the confidence interval of? That's it. All you're going to say. So if you're asking the confidence interval to people who would vote for you, so you would say, we're looking for we are 95% confident that the population proportion of people who will vote for me is between, and then finally, you're going to put the numbers we found there. Okay, so that's how you're going to interpret these type of questions throughout this entire chapter. So you can always use this to help you out when it comes to it. It's very simple, right? You're pretty much plugging in four things into this template, right? Everything else is going to be the same no matter what, which is also, pretty nice. Okay, so let's actually look at an example so you guys can see how this would actually work. So I have a little example already done for us, and we'll just go through it into this portion. Okay. Right. So example one says, according to an article in the San Gabriel Valley Tribune, most people are kissing the right way. That is, according to the study, the majority of couples tilt their heads to right when kissing. Pretty interesting, huh? In a study, a researcher observed a random sample of 124 couples kissing in various public places and found that 83 out of the 124, or 66.9% of the couples tilted their heads to the right. It's kind of weird if people look at you while you kiss, huh? Weirdos. Anyways, construct and interpret a 95% 95% interval for the proportion. So key thing, right? Here we go. Proportion of all couples who tilt their heads to the right. All right. One major thing we want to figure out first. Are we dealing with proportion or mean? What are we being asked to find? Confidence interval for proportion or mean? And now you noticed why I underlined that word there, proportion, right? Because that means now I'm under this situation. So if I go back over here, I should not be looking over here. I should be looking at this side, right? I'm only using this portion because we're under population proportion, meaning we're going to be doing P, we're using P hat, we're going to use z-scores, and we're going to be doing this portion, right? And we're going to be using this margin of error because that's proportion. Notice, boom, 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 down the line. So if we're doing mean, it's going to be down this way. So proportion. So the whole thing is find A, we're going to find the margin of error. Step two, verifying the actual interval. And then step three, interpretation. Okay, so that's your key hits, right? The question will always tell you what to be doing. You just got to be very wary of the big bold words that pop you out. And proportion, it's going to be that portion there. Okay. All right, now that we know we're doing proportion, next thing is we got to figure out a couple things, right? So according to our equation, we go back to our margin of error. We need a z-score. We need p hat, q hat, and n. Okay. Now, p hat is success, right? Just like when it came to binomial theorem, p hat success for in this case, since we're people asking for people that tilt their heads to the right, well, what is the proportion of people who tilt their heads to the right? And they gave us that, right? It's 83 divided by 124, or 0.669, right? Once we divide it. So that is success, right? Those are people who actually do it. Well, again, if you go back to that section, well, what was failure? So how many people do not tilt their heads to the right? Well, that means they tilted somewhere else, right? Left, middle, smack their faces, whatever like that. But that would be 1 minus it. So Same exact concept, Q hat is still 1 minus P hat, just like it was when it came to binomial distributions. So notice a lot of this comes back into play over and over again. Okay, so that's how we find Q hat, because that's failure to be, tilting your head to the right. Next thing is N, so sample size, so the total of 124 couples, right? So that was our sample size. And then finally, our z-score. Now remember, right, how confident do we want it? We wanted 95% confident. So therefore, all I have to do, and since it's proportion, right, we go back to our formula sheet, look at a little table here. It said 95%, which is right here. So our z-score will be 1.96. Okay, and that is how we get this value there. So all we're really looking for is four numbers: p hat, q hat, and the z-score. That's the four numbers you want before you plug everything into the equation itself. Okay. Now, once we have these four numbers, we go back to our equation and just plug it in, right? Plug and chug at this point. So we're going to plug in 1.96 here, find p, going to put the p hat times the q hat, divide by n, and the key thing is all inside the square root. So notice how this square root goes all the way to the bottom. A lot of people forget and just put the square at the top. It's everything's inside the square root. Okay, and I try my best to break it down when it comes to order operations. So inside the square root is considered a parenthesis. So timesing these two together should give you roughly 0.221. Next, you divide them. So and once you divide that, take the square root, multiply, and you should get a result of 0.083. Okay. Now that is our margin of error. So that is step one, finding the margin of error. Okay. Now the next step is we're going to add and subtract it to p hat. So remember, here was p hat. Okay, so we're going to add this number to this number and then subtract that number from here. So notice that's what we did here, right? Oh, actually I did the opposite direction. No, that's right. So subtract it and then add it. So you literally add these two numbers now. Add them and subtract them. And that's step two. That is the goal of this entire question. Finding that number, these two numbers there. Okay? So it's 0.586 and 0.752. And then finally, step three, the interpretation. Okay? So in other words, what do these numbers represent, right? That's the whole point. Why do we care about doing this kind of stuff? Well, going back to our template, we are, how confident? 95% confident that the population, well, what are we doing? What's our parameter? Proportion, right? Of, okay, what are we talking about? Well, notice all I did is copy exactly what we're looking for. That's what we're looking for. So all couples who tilt their heads to the right while kissing. So notice I literally copied exactly what we're looking for. That's what we want exactly in this question. Is between, so notice, is between, now we write the interval numbers. So it's between 0.586 and 0.752. So what this is saying is, if I broaden this out, so let's suppose, if I blow this out, so let's suppose now, so this is San Gabriel, so what if, everybody in San Gabriel, if I literally picked, or, looked at every couple in San Gabriel Valley and just see if they tilt their head or not, it's the proportion of people who actually tilt their head, it's going to be between these two numbers. That's the nice thing about this. It's not just a simple guess. It's going to be between roughly 58% and 75%, when it comes to it. And that's what the whole thing about a confidence interval is all about. Okay. All right, so now let's actually try one, from blank when it comes to it. Okay. So question one says, so a Gallup Youth Survey asked a random sample of 439 U.S. teens. Okay, so random sample, so I know that's going to be N, right? That's our sample. U.S. teens ages 13 to 17, whether they thought young people should wait to have sex until marriage. If the sample, of the sample, 246 said yes, construct and interpret a 95%, so here's my percent, confidence interval for the population proportion of all teens who would say yes if asked this question. All right, so I'm going to follow this example, right? Make these a little template here. So first thing we're going to do is find the margin of error, right? Well, in order to do so, we need to find a couple numbers, p hat, q hat, and our z-score, right? Because we're doing proportion. Okay, so n I already labeled there, right? So that's going to be 439. Okay. Now p had success, right? So what is the proportion of people who said that, or proportion of teens who said yes to this question? Well, remember, proportion is a percentage or a decimal, right? So, or a probability. Well, 246 out of 439. So, which means we just got to divide them. So, if we divide 246 divided by 439, that roughly gives us 0.56. Okay. So, therefore, to find Q, we just do 1 minus that, which should give us 1 minus 0.44. Okay. And now the last number we need is the z-score. And so we were 95% confident. So if we go back to our formula sheet, 95 is 1.96. So let's go over here. This is going to be 1.96. Okay, so now we got to find our margin of error. And that is, again, just plug it in to our equation. So if I look at my margin of error, right, all I'm doing is plugging in numbers where it's supposed to be, right? For every letter, just plug in the associated number. So it's going to be 1.96, all inside the square root. My P is going to be 0.57, oh sorry, 56. My Q hat is 0.44, all divided by 439. Okay, and now we just slowly break this down. So to help you guys out, I'll do this with you guys. So 0.56 times 0.44 gives it that, divided by 439 gives us a really small number. And now we want to take the square root of that. Okay, so all we did is just find that number, and then finally we got to multiply by our 1.96, our z-score, which gives us a margin of error of 0.046. And that's number one. So notice the whole work is just finding that number, because step two is pretty straightforward. We're going to add and subtract it to p hat, right? So now for step two, it is add these two numbers and subtract those two numbers. That is it. So if I add these two, so essentially it's 0.56 minus 0.046, and then 0.56 plus 0.046. So if I add and subtract respectively, here I should get 0.514. And on the other side, if I add these two, I should get 0.607. There we go. So if I say, now everybody in the United States, the entire population of teens in the United States, about 51 to 60% believe that waiting while having sex while before marriage should wait. Oh, sorry. We say 51 to 60% of all the teens, let's say, in the United States, not believe that waiting to have sex until marriage is, that's what they believe in, right? So we can broaden that up now to not just a simple sample, but everybody as well. And that's actually how we interpret it. So the last step is interpretation. So we are, how confident? 95% confident that the population proportion of, copy and paste, all teens who would say yes if asked is between, and then we just put the numbers, 0.14, 0.14 and 0.607. Okay. So next video we'll do a little bit more examples of that as well.